So this is kind of a preliminary research talk. It's got the first half of what I'm going to say is sort of a grand idea that will be probably obvious to some of you and probably interesting and novel to others of you. Hopefully even for those where you've heard the idea before and it's obvious, there'll be a few insights into how to think about it. And the second half of my talk is research questions that we're planning to look into in it. After I'm done, Andre will present a demo building on what we know how to do already here that we will then expand into covering all the interesting things we're planning to look into. So my name is Sandro Huck. I work for MIT at W3C, traditionally, but more into research now. Sort of a flexible boundary between the two. Joe can't make it today, and Andre will present next. I've already just covered my outline. So I want to start with something everybody's familiar with, which I would call the individual user lock-in problem. Anyone who's ever used software has discovered this problem, that you use software to create something, to do some work, and then you save your work and it's saved in a proprietary format. You're stuck in that software. And the only way out is by giving up on all the work you did, or reverse engineering the format, or maybe the software has some way to export to something that other things can import. But those last two are usually fairly lossy and error-prone. We've known about this for a really long time, and people have kind of gotten around it by using open source software or using standard formats. So this is old hat, and it's an ongoing struggle in the computer industry. But more recently, evolving over a long time, we have what I would call group lock-in. This is where you have a network effect among the people using a software, where the more people using the program, the more value it has. Sort of my pinpoint case of this is if I want to share my photos, access control to a group of people on Flickr, everyone has to get an account with Flickr and use Flickr to get access to it. Right? We all know this, and obviously Facebook is all about this, and has this network effect going on, and that's why this company that doesn't do much is worth so incredibly much money, because people see that value there. And you can imagine if Facebook were actually where they want to be and thought they were going to be, if they'd taken over the world so that everybody used it, then everybody would have to use it. Right? The only way to get something to everybody is to use the platform that everyone else is already using. Facebook hasn't actually gotten that far. People seem to resist that. I bet most of the people in this room don't actually use Facebook much, given this crowd. So we're stuck using things like the Postal Service and telephone and email, sort of the things that everybody can use that are free and open and decentralized. But that's not nearly as functional and interesting as you could do with modern software. The flip side of things, of users being locked in, is that developers and innovation are locked out. If you have some cool innovation and you want to get it out to the users, you can't because they're trapped in somewhere else. For instance, if you made a new and better Facebook, well, it would have no value to users because there'd be no other users using it. You have this bootstrapping problem. Like, all the users are on Facebook, you've got this better thing, but they won't come there. One comes and it's empty, it's ghost town, why would they use it, and they go back. I think we've seen this with a couple people trying to claim something else that would be better. Twitter and a few other things have a different angle and are sort of inching in there. But it's a terrible battle for the users. And it stifles innovation terribly. These platforms do let you build on them. If you have some improvements you want to do, sometimes you can build it on the Facebook API or the Twitter API or such. But then there's limitations. If you get in their sites as a business, then they just change their API or lock you out. And there's horror stories there, so no business really wants to build on that. So the question is there a better way? Here's an example of where we are applied to meeting scheduling. So there's lots of different meeting scheduling systems out there. The one I and everyone I know uses is Doodle, but all these others exist, or they did when I made this slide. But obviously, if Alice and Bob want to schedule a meeting together, they have to use the same system. Right? This is what we're used to. And so you end up with this tremendous network effect around one thing. But since everyone won't use it, they're splintered and you can't talk to everybody. So we proposed instead. So notice that each of these things has this database, which I've drawn as this standard database icon here. So each of the systems has its own database. And the change in architecture we propose is that instead the databases go with the users. So Alice has her database, and Bob has his database, and all the applications talk to the apps and then through to the database. So the data remains in control of the users. And we'll get into this in more detail. So this is what I call the cross-cloud vision. The user's data remains on general purpose server, responsible to the user. The users can expose it to any application they like. Users can switch providers when they want to. Applications, ideally, provide the same functionality we're used to now, but with external data. And this is the technical challenge, how to do that. And then, of course, this is built on RDF. The data always being in RDF, because that's an open format, fully as powerful as you need. And the data is accessed via HTTP, because again, that's an open protocol. So the linked data platform, coming around to the technologies we're looking at to do this. The linked data platform starts with the basic idea of linked data, which Tim Berners-Lee proposed, I think, in 2006, which is that whenever you're writing data about something, you use working HTTP IRIs to name things. If you reference those, you'll get data about the things. Very much like the web page, but in a machine-readable form. The idea of the linked data platform is we extend that to being not just readable data, not just following links, but actually read-write data, where it becomes more of an object store or a data store for your data. On the standards track, this has been evolving at W3C for about 2 years now. A group of companies sort of spearheaded by IBM, but also you see them listed here, Dara, EMC, Oracle, Red Hat, Semantic.com, and TaskTop joined in and said, well, let's make a standard for doing this. So a working group was formed that's been running for about 2 years now. Andre and I are members of that. They had a last call back in June, I think, got a lot of feedback, went back to the drawing board on some things, had another last call which was published today, coincidentally. And that means the working group believes it's finished their design work and is interested in public review. So by all means, take a look at the URL here. You can probably even remember that, or Google LDP. But what LDP as a standard is right now is very, very simple. It provides containers, which is this notion of a resource on the web that you can post to, and it'll save that information at a new URL. This is just like people do all the time with web APIs right now. RESTful APIs do this, they have an API. If you want to send something to the server, you post to a URL and it puts it somewhere. And then you get that container, and you get a bunch of RDF triples that will link to all the things that you posted, or somebody else posted. So it's really just a sort of trivial pattern, but it's useful. And there's the spec provides a bunch of nuances and different ways you can do it, different ways you can map to RDF. That may not be that interesting. The main point is that you can do this in simple ways. The other thing that the group really tried to do, and it's not in the spec that came out today, but should be in another spec out in a couple weeks, is paging, which is when there's a graph that's too big, or say a container of 1 million items or 1 billion items, you can't just do an HTTP GET and get 1 billion triples and have that really be a very responsive user experience. So paging is, instead of getting the whole thing, you can get the first page or the second page or the third page, each with its own different URL, and they're linked to each other through headers. And you can, in some situations, you can specify an ordering. So often, if it's, let's say this is a list of events, you probably only want the most recent ones. You don't want all the events through history. And so if you get them ordered by events, you just get the first couple pages and that's all you need, even if there's 1 billion of them. That's fine. So what these show is that we can use existing, very simple HTTP mechanisms, HTTP link headers, RDF, and sort of built-in HTTP extension mechanisms to build more functionality into RDF. And that's a lot of, into linked data to make it a triggered object store. And that's really what our research is about. That's what I just said on the slide, those extensibility mechanisms. One thing people like to do with HTTP that we can't do is use new media types. If you talk to RESTful APIs, they often have media types for this, media types for that. And the problem is we're already using all the media types for different RDF formats. So we have turtle as a media type, and RDF XML as a media type, and JSON-LD as a media type. So we can't really have the different media types be different operations you want to perform, or anything like that. But we've found So in today's demo, the functionality we have today, we're using a couple extensions that are not in LDP as it is today. There's web IDs, which is the idea of using IRIs to identify people. And then you dereference that, and you get information about the person. I mean, obviously, you're used to this. People have profile pages all the time. But to actually use this as part of the login mechanism. And Andre will show you how that works in the demo. Workspaces where you dereference the web ID, and in the person's information, there is some URLs for application workspaces, where applications can read and write data. Change propagation. Right now, the web doesn't really do change propagation very well. You can post to a site, and you can get, but you'd really like to be able to watch a site, and the instant something posts, you get notified of it. And there are a bunch of tricks in the web application developer handbook, long poll, and WebSockets, and so forth. But to actually pick one of those, so we don't actually have this in Andre's demo. Joe's demo had this using WebSockets. We're still exploring what's the best way to do that, and sort of down the road, the linked data platform will include some more standard mechanism for that. Also, obviously, access control is a big deal. If you have read-write stuff out there, you can say who can read, who can write. And we have a basic version of that, but we're exploring ways to add to that. I'm going to make this a little bit more real with a hypothetical application, a to-do list application. This is kind of the hello world of web apps. I don't actually have it running right now. I'm just going to sketch out what the protocol might look like. So here is a normal web app today. Alice wants to use her to-do list manager, so she goes to acme-to-do-list-manager.com. And first she has an interaction to get some application web page. I have it called app.html. That probably gets app.js, a bunch of JavaScript. That begins some login process when she clicks a login button. And then maybe she does get to see what's on her to-do list and post to update the to-do list. Sort of the basic HTTP protocols. And so the main change we make is that we move some of those things down to the server she controls. So the original web page and the JavaScript still came from the application developer. But then the actual data store, both the login process and the get and the post, go to her own store. Which is simple enough, but it means that now if she wants to go to some other to-do list manager, she's still got her data, and she just gets a different user interface to it. So that's a huge win. And then maybe she wants to do a shared to-do list with Bob. So all she has to do is grant him access control so he can get the items on her to-do list. And now we've got a shared social to-do list.
When you share,
Yeah.
do you enable which ones are publicly available and shared, which ones are private? So going to see doctor for that tumor is not being shared with Bob.
Right. So in the demo, Andre will show you how you can do that in our app. Basically, that's up to the user interface design. The protocol we imagine is fine-grained, or has the granularity of URLs. This particular URL is available to this person, this particular URL is available to this person. But LDP is flexible about what you put at which URLs, so you can basically divide your data with whatever granularity you want. But this is also subject for research, so we don't know exactly what the best way to do that is. So, yeah, why is this so great? You can run other user interfaces, so you get the flexibility about user interfaces, and you get out of the social lock-in. Because now, when in this situation, shared to-do list has a bunch of new features, and those are available to everybody. They didn't have to switch their data, they didn't have to migrate, they didn't have to switch to a different bunch of users. You can just evolve the software. Yes?
But you do have to have an agreement on what the data items are, right? Or something about the schema in order to be able to do this switch between.
Right, and that's exactly the sort of thing we're used to with RDF, which is if you agree on the RDF vocabulary you're using, then you're all set. If you don't agree on the RDF vocabulary you're using, then you need some kind of mapping, rules, or translation system, which is a later slide.
Another question on the diagram?
Yeah.
So how does shared to-do list, Bob's shared to-do list interaction, how does it know to go to find Alice's server?
So you can imagine a couple possible interactions. I mean, in this case, I'm imagining Bob says, I want to look at Alice's to-do list. And so he uses the URL of that.
Okay, so he knows Alice's.
Right, or there's some directory service, or they're connected in some social graph way.
Right.
There's a lot of possible ways that could be done. We don't have any particular magic. A couple other points that Alice's, it's a commodity backend. So, alice.databox.net is a commercial service, we imagine. I mean, it could be run by her school or her employer, but probably that's a commodity service like web hosting is right now, where she pays $5 a month or $6 a year. Maybe she gets it for free if she's willing to let them mine her data for control rights. I don't know why anyone would do that, but probably someone would. But the point is, it's an open market and she can move between them. Because of that, she has control. Right? She can pay and not have her data mined if that's what she wants. I'm not saying this will keep out government surveillance necessarily, but at least it makes surveillance not part of the business model the way it is in the current one. Another benefit of this is that we don't have a password proliferation problem because she only has to authenticate herself to her one, or maybe she has a couple of these providers, which is a very small number of passwords. She's always authenticating to that. She doesn't have to authenticate to each different app. So that solves that.
Why she doesn't need to log into the other one?
Because all she's getting for an even better to-do list is some software. She's getting app.html and app.js, and those pieces of software are just operating on her.
Why would a software provider want you to log in so that they know who's using the software?
So what does even better to-do list.com get out of it?
So I'm not trying to restrict the business models here. They could require that she log in with them and pay the money or offer her privacy up to them, but they don't have to. They could also charge her $1 a year or $1 per version. If this is a phone app, that's the standard model people are used to for phone apps instead of web apps, and all this applies to phone apps too. So it's not that she necessarily is privacy protected, but she doesn't have to give it up to get all the functionality that she gets today. And we figure, or we're guessing, that the market of the free market of people is a lot of them are going to want to preserve their privacy and not tell everyone to do.
In this model, which is somewhat database-centric, somewhat software-centric, I guess that's Alice was Alice. If Alice wanted to have her phone in her hand and she's on the plane and wants to look at her to-do list, then she also want to clone a copy or some way to sort of look at data without having that connectivity.
Right. Because we have a very simple data model of RDF behind all of this. So in theory, it should be pretty easy that she has a cloned copy, a web cache. Managing the cache consistency, if she makes changes in two different places, obviously is a hard problem, but it's easier with RDF because at least we understand RDF really well, and it's all just triples. So it becomes about as manageable as it could be. Okay, I'm going to go on and ask some questions of my own. Actually, first, just to mention other applications. Obviously, the to-do list is a sort of hello world. The first thing we're really trying to build is microblogging. Basically what Twitter is and what I think Facebook is for most people these days. Most people seem to use Facebook just for status updates, at least in my social group. So again, that's microblogging like Twitter. So we're building an app called Simba, and that's what Andre's going to be demoing.
So this standard also includes an ontology for that RDF data?
So Simba actually basically reuses existing RDF terms. We might have to make some up, but I don't know that we had to make up any. We haven't had to make up any so far. You could, of course, make Office apps, stuff like Google Docs has now, and this is what Joe was going to demonstrate. He has a spreadsheet, very, very low functionality spreadsheet, but still it does a spreadsheet, collaborative between people. Yeah?
All right, I think I get it, at least as I get it. It seems kind of brilliant. The notion is that any individual kind of builds what in my mind would be analogous to their own website, except it's this large collection of data. And then anyone else can build applications. And the commercial side of the world sits in the application development, and my data sits in my world. So I just have a big store of RDF data.
Exactly.
It's a win-win.
I think this is incredible, actually.
Good. Other applications we're imagining interest in very soon. Media sharing is an obvious one. I mean, sites like Flickr all the way to YouTube, whether it's video or still, everybody's generating media all the time with their phones now. So to be able to share those with more control out of servers that perhaps run their basement or their office or are commercially leased, we think there's a lot of potential there. Product reviews and feedback, another great social place. You know, all the reviews you post around the web probably ought to be on your own server. That would be a nice place to have them track back to you. I'd be interested in seeing this kind of stuff used for gaming too. Right now, gaming systems tend to have all their proprietary protocols, but having some of those up and up would be fun. But you can go on and on. So much software these days has a social component. So back to the research question, I want to say that this work is being supported by and in collaboration with QCRI, which is the Qatar Computing Research Institute. And if you're available to move to a very nice Middle Eastern country, they are hiring. I'm assuming you qualify. But they're great fun to work with. And we have related work supported by the National Science Foundation and the Knight Foundation. And then I list our folks here. Tim Berners-Lee, I imagine most of you know, has joined us in the room. I wasn't expecting him, but Tim is the PI on this work. Ashraf Al-Naga is the PI at QCRI for this, and then listed other names here too. So what are some of the research questions that we'd like to see answered here? But I sketched out how it could work, but to pin that down a little bit more, one of the big questions is how we do efficient change propagation. I mentioned this. It's tricky talking from web servers to web apps instead of just web apps to web servers, going both directions there. Getting this to scale. In Twitter, we have cases up to people following millions of people, people being followed by millions of people. Getting those changes to traverse through the net in some open distributed way. We think there are algorithms for doing that economically and efficiently, but that's going to be something going forward to prove how to do. Access control, the very simple access control of saying this URL is available to these people to read and these people to write. Yeah, we know how to do that, but that's not actually what people want. People probably want something much more flexible around attribute-based access control, like my friends can read this, so there's at least groups. That's pretty straightforward. Making that available so that people can really understand how to use that and not get themselves into trouble is definitely a subject for research. Writability is, I think, for me, is the most interesting question here. Because I don't think you necessarily want to say people get to write to my server. I would rather they write to their server and notify me that they did so. And then it becomes a question of which notifications I choose to follow and which things I choose to believe, which is kind of like the normal semantic web. There's dirty data and clean data, how do I integrate those in a consistent way? So that's sort of